Take a quiet moment and look around the room you are in. Every object, every memory, every person you hold dear is in motion. Not just the gentle spin of the earth or its lap around the sun. Your entire world, your entire solar system is part of a vast, silent current sweeping through the galaxy. We are all passengers on a 4.5 billion-year journey, and at the heart of that journey, 26,700 light years away, is the destination we are always circling but never reach. It is a hole in space-time, a quiet shadow 4 million times heavier than our sun. Everything you have ever known has been orbiting this abyss, long before there were eyes to see it. Our speed on this journey is immense. The sun carries us all at roughly 220 kilometers per second. At that pace, it still takes us about 230 million years to complete one single orbit of the galaxy, one galactic year. Since our sun first ignited, we have made this lap only about 20 times. All the dinosaurs rose and fell in the course of a single lap. The continents we know today drifted into place during the most recent one. Entire mountain ranges have been pushed up and eroded to dust, all while our solar system traced just one more section of this immense ancient circle. At the center of this motion sits our anchor, Sagittarius A star. It was first detected in 1974, not as a hole, but as a mysteriously bright and compact whisper of radio waves. For decades, it was just a point on a map, but as we watched, we saw that this point had an almost impossible gravity. It contains the mass of 4 million suns, crushed into a space so small that its shadow, the dark region cast by its event horizon, would comfortably fit inside the orbit of Mercury. An entire city of stars worth of matter, packed into a volume you could cross in a single day, if you could travel at the speed of light. But how do you weigh something that is invisible? You watch what it does to the light around it. For nearly 30 years, astronomers used telescopes in Chile and Hawaii to conduct a patient vigil, tracking the stars closest to the galactic heart. One star named S2 became their stopwatch. Every 16 years, it completes a tight, elliptical loop around the unseen center. In 2018, it made its closest pass yet, diving within 17 light hours of the black hole's edge. It accelerated to a staggering 2.5% of the speed of light. And as it did, its light stretched, shifting toward the red end of the spectrum, exactly as Einstein's theory of relativity predicted gravity would do. Its orbit even twists slightly with every pass, a subtle dance choreographed by warped space-time. This star's loyal orbit was the final proof, the act of placing the invisible on a cosmic scale, an achievement that earned the lead astronomers a Nobel Prize. Then, in 2022, we saw it. Not the object itself, but its silhouette. The Event Horizon Telescope project did something extraordinary. They linked radio observatories across the entire globe, from Antarctica to Spain to Arizona, synchronizing them to act as a single telescope the size of our planet. They needed a lens that big to see something so small, so far away. What they captured was the faint glow of superheated gas swirling around the edge of the abyss, framing the dark circle where light can no longer escape. On our sky, that ring is only 50 micro-arcseconds across. That is the apparent size of a single donut, sitting on the surface of the moon. Humankind built an eye the size of a world, to see the shadow of a ghost at the heart of our galaxy. And yet, for all its immense gravity, our black hole is unusually quiet. It is a sleeping giant. It glows about 1 billion times fainter than it could if it were actively feeding. Most of the time it starves, only occasionally flickering with small flares of X-ray and infrared light when a stray wisp of gas falls in. A few years ago, a dusty object called G2 skimmed by, and astronomers watched, expecting fireworks. But the black hole barely stirred. It seems a placid giant now, but there are echoes of a more violent past. High above and far below the galactic plane, astronomers have found two colossal bubbles of gamma-ray energy. These are the Fermi bubbles, each one 25,000 light-years tall, vast, ghostly structures that appear to be the remnants of an enormous eruption from our galaxy's core. They are cosmic smoke rings, hinting that a few million years ago, as our own distant ancestors walked the Earth, our sleeping giant was awake and roaring. So is this quiet giant what our sun is orbiting? The truth is both simpler and more profound. The gravity of Sagittarius A star is overwhelming, but only in its immediate neighborhood, the central few light-years of the galaxy. Out here, in the suburbs, its direct pull is negligible. We are actually orbiting the combined gravity of everything: the 400 billion stars in the Milky Way, the countless clouds of gas and dust, and most of all, the vast, invisible halo of dark matter that surrounds the entire galaxy. The black hole doesn't steer us directly. Instead, it sits at the one place all that mass balances out. It is the near motionless center, the calm eye of the hurricane, the pin in the cosmic map around which everything else turns. Because of its great distance, we are always looking into the past. The light from the galactic center that reaches our telescopes tonight began its journey 26,700 years ago. When that light left, humans on Earth were painting scenes on cave walls, and the great ice sheets of the last glacial maximum had only just begun to retreat. Every flicker, every flare we witness from Sagittarius A star is an echo from a world we can never visit, a ghost of light from before the invention of writing, before the first city. We are in a slow, one-way conversation with the heart of our own galaxy, receiving messages from a time long since past. Now, come back to your room, to this moment. Feel the stillness. It is an illusion, but a beautiful one. Our entire lives unfold in a tiny fraction of one galactic year. We are born mid-lap, and we leave mid-lap. We are temporary riders on a slow, grand carousel, circling a silent shadow we have only just learned to see. But the motion itself is not temporary. It began long before there were eyes to notice it, and it will continue long after they close. The universe is in motion, and somehow, for a brief and precious time, we get to be aware of the ride. If this sense of cosmic scale is something you enjoy, consider subscribing for more calm, cinematic journeys into the universe's greatest wonders. Your support helps more people find these quiet explorations of space and time. Thank you for joining us on this orbit. We will see you on the next one.